Hey guys, hope you're all doing well. This is part two of, well, it's in a textbook. Blitzer is what I'm using, pre-calculus. It's part two of 4.2. And the topic that we've been working on in 4.2 was unit circle trigonometry. So I'm going to continue where I left off. Here we go. So we were looking at unit circles, knowing that it is centered at the origin and it has a radius of 1. And we established there were six functions. You've got cosine and secant. Okay, these are called reciprocal functions right here. And we are considering those also to be even functions. Now, even functions have the symmetry. Later on, when we take a look at the graphs of these functions, you'll see what I mean. The symmetry with even functions are with respect to the y-axis. They have what's called y-axis symmetry. Like a parabola could have a y-axis being right in the middle with the vertex on the y-axis. So cosine and secant are considered even functions. Odd functions are the other four that you see right here. Definition, formal definition of in algebra or pre-calc, if it's an odd function, an even function, whatever the x values are, if you take the opposite values, it'll get you right back to the positive. So these are positive x values. These are the same numbers, negative x values. They yield the same y's. They yield the same y values. So if x is, these are angles, if x is 30 degrees and this is negative 30 degrees, then the y values are identical. That's what it is said to be an even function. So in this case, this is quadrant 4 here, and quadrant 1. And if you look at the y values, that's what we're looking at, the y values. This is negative pi over 4 right there, and this is positive pi over 4. Equivalent to that is degrees is 45 degrees. Okay, so if I let x be root 2 over 2, if I let the angle be pi over 4 and the opposite of pi over 4, then this says that the result, which is what's the cosine of negative pi over 4 and pi over 4, it turns out it's the x value. So here's the x value right here, and there's the x. You get the same output, which is the x values. That's just a demonstration of those being even functions. And if it's odd, sine is really odd right here. And if you look at, again, pi over 4 versus negative pi over 4. So negative pi over 4 is here, pi over 4 is there. So let's see what that yields. Okay, these are the y values. Looks like the y values are opposite. And that's true. That tells you that if f of negative x is equal to negative f of x. This is for odd. So this says if you, like pi over 4, if you let it be negative pi over 4, here the answer is negative root 2 of 2, which is the same as the opposite of sine of pi over 4. So it's the same thing. Okay, some other problems. Again, the other trig functions right here. You know there's 4 others. There's 6 total. 6 total. I'm looking for my pen. Give me a moment here. Oh, there it is. I'll use this one. If I want the other 4, I have sine and cosine. How about cosecant of theta? That's going to be the reciprocal of this. So that's 5 over 2. reciprocal function of cosine is secant. Reciprocal of this, so that would be 5 over root 21. Let's see, the other two, tangent, the other two is tangent. So the tangent of theta, well, that's the same as sine over cosine. So what do we got? 2/5 over root 21/5. Okay, that's 2 over root 21. Now, that is an answer. It just has a radical in the denominator. To rationalize the denominator, if in fact that's what you need to do, you multiply top and bottom by itself. And so what you'll end up with is 2 root 21 over, well, that's just plain old 21. So that's an answer with the denominators rationalized. And the other one would be cotangent, which is the reciprocal of that, which is the reciprocal of this in blue. So root 21 over 2. Okay, different variable, phi. That's the Greek letter phi. So similar kind of problem. Sine, how about doing cosecant of theta is equal to 3/2. Secant theta is equal to 3 over root 5. So if I wanted to rationalize that denominator, then root 5. So that gives me 3 root 5 over root 25. Oh, but square root of 25 is 5. So 3 root 5 over 5. Tangent. I put theta and it's supposed to be phi. I do that every once in a while. This should be phi, not theta. So tangent of phi. Okay, sine over cosine. Look at the 3's will cancel. So ultimately it's 2 over root 5. Or rationalizing the denominator, you get 2 root 5 over 5. And then cotangent. Take the reciprocal of this, so you get root 5 over 2. Okay, a little different problem. I've got one trig function, and I need 5 more, but this little bit of information is going to help you find the rest of them. Okay, this right here, it's saying the angle t. So that's not a Greek letter. The angle t is, the letter t is not a Greek. It's just a standard R letter of the alphabet, lowercase t. So t is trapped between these two angles. What quadrant is this in? So this is in, it's got to be smaller than 3 pi over 2, bigger than pi. Well, that's in quadrant 3. So if I went over here in quadrant 3, knowing this is a unit circle, and you can always inscribe a right triangle inside a unit circle, then this is going to be negative 3/5 is the y value. This is 1 right here. This right here is negative 3/5. How you go about finding the x, which happens to be negative, by the way, because it's to the left of the origin, you use Pythagorean theorem. Or formula, which is x squared plus y squared is equal to r squared. Don't know x, so x squared plus, okay, negative 3/5 squared is equal to 1 squared. X squared plus 9/25 is equal to 1. So what I'm doing is trying to solve for x, because I'm going to need x, which is the cosine piece, for everything else. So you got x squared is equal to, that's 25 25ths. This is 25 over 25 minus 9 over 25, which is 16 over 25. So if you take the square root of both sides, you're left with plus or minus the square root 16 over 25, which means you have a choice, plus or minus 4/5. But because x is on the left-hand side of the origin, this has to be negative 4/5. And now I have enough information to do my other trig. So I'll do it up here. I need a cosine of the t, which happens to be the x. Reciprocal cosine is secant, which is negative 5/4. Oh yeah, the reciprocal of sine is cosecant, which is the reciprocal of this, which is 5/3. Okay, cotangent and tangent. Let's do tangent first. Of t. Okay, tangent is sine over cosine. Two negatives make a positive. That's on the top, that's at the bottom. Fives go away. So 3/4. Tangent is 3/4. Therefore, cotangent is 4/3. Okay, and the last one here, similar. This is telling me that it's got to be smaller than, well, pi is the same as 180 degrees. So smaller than 180 degrees, bigger than 90 degrees. It's trapped between 90 and 180 degrees, or quadrant 2, Q2, Roman numerals. So similarly, what I'm going to do is go like here, here, right triangle. If you want to do the circle, you can do that. You'll find out it's not necessary. The right triangles work great. That's in the next section, is right angled trigonometry. Sine is the y value. Okay, so y is a half. So that means this is a half. You're looking for x, and that's a 1. So here we go. We go 1/2 squared plus x squared is equal to 1 squared. 1/4 plus x squared is equal to, what, 4/4? So x squared is equal to 4/4 minus 1/4. X squared is equal to 3/4. X is equal to plus or minus, if I haven't made a careless mistake. Doesn't look like it. Square root of 3/4. So x equals plus or minus root 3/2. And I'm going to choose the negative because, again, it's to the left of the origin. This is negative root 3/2. So here we go. You've got sine. You need 5 others. So let's start with cosine. I said cosine. Cosine. Okay, that's the Greek letter right there is beta. Greek letter is beta. So cosine of beta is equal to the x, which is negative root 3/2. Reciprocal of this is secant. Negative, 2/√3. Or if you took and rationalized the denominator, it's negative 2√3/3. Reciprocal of this is cosecant. And that's 2/1, or 2. Cotangent of beta and tangent of beta. Okay, tangent is the y over x. Tangent is y over x. Oh, y, this is your y right here. over x. So 1/2 over negative root 3 over 2. 2's cancel. You'll find out that this is negative 1 over root 3. And cotangent would just be the reciprocal of that. So negative root 3. Maybe this is the last thing that I've got to take a look at. Let's see if it is. It is. So the last thing that we're going to look at is, again, unit circle. Yeah, you'll see ordered pairs at the edge. Now there's another better picture on this side if you need it. But the unit circle, I'll try to find out. Let's do this one first. 5 pi over 3. I'm looking for 5 pi over 3 right here. That would be right here. So that's ordered pair is what I just underlined. Tangent is y over x. So it's negative root 3 over 2 divided by 1/2, which is what, negative root 3. Let's do, since I'm on tangent, let's do 300. Well, you know what? 300 is right there. So it's the same result. So that's going to be negative root 3 as well. Same result. Let's do this one. 11 pi over 6. So again, I'm looking this way. So 11 pi over 6 is right here. Cosine is the x. The x is right there. So root 3 over 2. Root 3 over 2. Now, if you're not sure if this is actually true, here's what you can do just to check. If I use my calculator, I'm using a TI-84, and this is a radian right there, not a degree. So remember last session, 4.1 or introduction to trig, I said you got to check the mode right here every time to make sure you're using the right mode. You see, radian is good. If it was on degree, I'd have to change it over to radian because I'm using a radian right here. Okay, so now looks good. Clear that out. I want the cosine, 11 pi over 6. Cosine, 11 pi divided by 6. By the way, if you want to know where I got that little fraction, 83 users, you don't have access to that calculator or that feature. 84s will if you have an upgraded operating system. I did alpha, y equals, and it gives me this dialog box. If you don't have the dialog box, you don't have what I just did. N over D, numerator over denominator. And if you press 1 or enter, you'll get a fraction. So I don't want that, of course, so I'm going to have to delete that. Okay, so I put that in. I wonder if it's root 3 over 2. It's not exact. So I'm going to take root 3 over 2 and see what the decimal approximation is. Same thing. So this is good. That's a good answer. Let's do this one. Okay, negative 3 pi over 2. So what I need to go is I need to do this direction right here because it's negative. So here's pi over 2. Negative pi or negative 2 pi over 2 and negative 3 pi over 2 gets me right there at that terminal side. So I'm right here at that ordered pair and I'm looking for signs. So I want the y, which is 1. Cosine 9 pi over 4. So I'm going counterclockwise, 9 pi's over 4. So I'm looking over the 4s. There's 7 pi over 4. Right here is 8 pi over 4, which is the same as 2 pi. See, so right here is the same as 9 pi over 4. What I did is I went around and stopped right there. 9 pi over 4. And since it's cosine, I'm looking for the x. The x is positive root 2 over 2. And now finally, I'm looking at the cotangent. Now, negative 5 pi, that, again, that's going to go clockwise. So I'm going to go this direction. I got to see where I stop at negative 5 of those pi's. Negative 5 of those pi's. All right, so here we go. It's going to get messy. Here we go. Okay, there's negative 1 pi, 2 pi, negative 3 pi's, negative 4 pi. Right, negative 5 pi gets me right here at this terminal side. So it's the same place as pi, actually. And that's the ordered pair. I want cotangent. Cotangent is x over y, because tangent is y over x. So x over y, negative 1 over 0. Aha, that is undefined. That's the phrase we use, is undefined. Yeah, that's the phrase you want to use. Okay, let's see what we got. I think we're done. Yep. I'm done with 4.2, or unit circle trigonometry. Next time, you'll see the next, oh my gosh, I can't even say, the right triangle trigonometry. And those of you using Blitzer, it would be section 4.3. Okay, take care.